In today's session, we're looking at balancing equations. All right, so we've looked at, last session, we looked at formulas, we looked at changing word equations into symbolic equations, but we didn't balance them. Today we're going to balance them. And the key idea here is once you have a formula CH4, O2, CO2, H2O, you cannot change these formulas at all right? But you can change how many molecules you've got. You'll see what I mean. So CH4 plus O2 goes to CO2 plus H2O. Now, I don't like this method, but this is a method taught in schools. I prefer more of a understanding and problem solving approach. So I'm going to show you both, but I'm recording this and I'm going to put this intro on the actual Miro board so you can get a really good taste of how to do it. So this is how schools are taught to do it. Well, so we look at carbons and we look at hydrogens and we look at oxygens. Now on this side, I've got one carbon here. I've got one carbon there, one. Hydrogens, I've got 4 hydrogens here. I've got 2 hydrogens there, O2. I've got 2 oxygens here. And I've got 2, add 1, 3 oxygens here. It's obviously not balanced. And the way to look at it is, well, I've got far too many hydrogens here. I've got 4 and I've only got 2. So I look for what I've got the most on my left-hand side. And the only way to make these two numbers the same, and that's what you're going to do, is to times this by 2. And the only way to times that by 2 is to put a big 2 in front of here. You now have 2 water molecules. 2 times 2 is 4. Yay, I'm happy. That's not the end of it though. Since I've increased the number of hydrogens, I've also increased the number of oxygens. And the number of oxygens now, 2 times 1 is 2. So down here, the oxygens, I've got 2 times 1 is 2, plus these 2 here. Let's write it over there out of the way. I've got 2 oxygens here, 2 oxygens there. 2 add 2 is 4. So I need to change that to 4. Now that I've changed that to 4, well, this is a 4 and that's a 2. That won't do. I need to times this by 2 as well. If I look at it, there's O2. If I put a big 2 in front of there, I've got 2 times 2 equals 4. So I've got 4, 4, 1 and 4, 4, 1. My numbers are all the same. I'm balanced. I'm done. This is how you do it. All right? And this is how you balance it. Now, you must have exactly the same things on the left and the same things on the right. So this is method 1 of doing it. So I shall show you my method. So I don't write everything down. And it takes a lot of patience to do it my way. CO2 plus H2O. So I look at this and I think, right, okay, it's obvious that I've got 2 hydrogens there. So I look over it and I think it's obvious I've got 2 hydrogens there and 4 hydrogens there. I think, right, that's where my hydrogens are coming from and I don't have enough. So I would times that by 2, all right? Just to make my hydrogens same. So I've got 4 hydrogens here. Now I've got 2 times 2, 4 hydrogens there. Now I'm going to look at the number of oxygens. I'm not going to look at the number of carbons because it's obvious I've only got 1 carbon, so I don't need to change that. So I'm going to look at my oxygens. I've got 2 oxygens there. I've got 2 times 1, that is 1 oxygen. 2 oxygens there, so I've got a total of 4 oxygens. If I've got 4 oxygens on my right, I must have 4 oxygens on my left, so I must put a big 2 there. 2 times 2 is 4. Okay, so let's pick another one, all right? And I'm going to do this my way. The actual equation is Fe2O3. Cannot change this formula plus carbon. All right? Goes to Fe plus CO. Well, the first thing I'm going to look at is my iron. I got 2 irons there. I've got 1 iron there. Well, I need 2, but I need both on the same side. The second thing I'm looking at is my oxygens. I've got 3 of them there. I've got 1 of them there. Well, I need 3 of them, so I'm going to put a 3 here. Okay. So now my oxygens are balanced, but now I've got 3 carbons. 3 carbons. I've only got 1 there, so I'll put 3 here. I am done. Right? Otherwise, this is the working out you're doing. And if you look at Fe2O3, 3 carbons, 3 carbons, 2 ions, 2 ions, 3 carbon monoxides. All right, one more. All right. So the next one I'm going to look at is magnesium plus nitric acid, Mg. And we looked at, oh dear, that should be plus, Mg plus HNO3, HNO3 goes to Mg, NO3, and I've got 2 of them, plus H2. Okay. Now, that's what you're given. You cannot change that, that, and you can't put a 2 there. You cannot put any other number there. Those are your formulas. All right, so what do I notice? Well, to be honest, the first thing I noticed, I got 1 hydrogen and 2 hydrogens there. You just got to look at everything. I'm just going to pop a big 2 there. And now that gives me the same number of hydrogens. When I look at my NO3s, unless it's changing, and it is not, I look at it as one thing, not as 1 nitrogen and 3 oxygens. I look at it as a nitrate ion, NO3. Well, I've got 2 of them here. I've got 1 written there, but I put a big fat 2 in front of it. So 2 times 1 is 2. And here I've got NO3 and a 2 on the outside, and I've got 2 of them there. That's it, I'm balanced. And all I did was look at the hydrogen. And again, look at the working out you're expected to do. I don't like it. All right, so that was magnesium. I'm going to do sodium. Sodium and water. Sodium plus H2O goes to sodium hydroxide. Plus hydrogen. All right, straight away, I'm going to pick what I look at. Right? My hydrogen look all right. My oxygens look all right. All right? Actually, my hydrogens don't. I've got 2 there. I've got 1 there. I've got 3 hydrogens here. Well, that doesn't help, does it? I've got 3 hydrogens. I need more hydrogens over this side because I've only got 2. So the first thing I want to think about is I've got 3 hydrogens on my right. They are not the same. So I can't change that to a 3. So I've got to increase that. I've got 2 water molecules. All of a sudden now I've got 2 2s of 4 and 3 hydrogens here. But I've also got 2 times 1 is 2 oxygens. Well, I've got 1 oxygen on that side, so I'm going to put a big 2 there. Oh, well, if I put a big 2 there, I've just doubled my sodium. I'm going to have to put a big 2 there. Now let's check it. Hydrogens 2. 2 times 1 is 2. That's 4 hydrogens. 2 times 2 is 4. 2 times 1 is 2 oxygens. 2 times 1 oxygen there is 2. 2 sodium. So I'm balanced. All right. Okay. That's what you need to do. All right. And these are your questions here. If you do not try these, and this is where you learn by trying. You get it wrong, I don't care. All right. I saw this really good image. Oh, I'm going to see if I can find it for you. And I was having a conversation with a bunch of guys from, they were lecturers at Cambridge. And they were saying it's all about trying something. All right. And this is not easy. It's one of the toughest topics in chemistry. It's also one of the more fun ones because you can develop your own way of solving it. And that's why I don't like the, oh my God, boring way of doing it in school. You know, I just don't. I just think it's horrid. Like, where have I put you guys? I've lost you guys. All right, I'm just going to stop this recording. 9 minutes. Yeah.